In this lesson, we're going to take a close look at the source code for the Google client. First, however, I'd like to review the distinction between a key store and a trust store. So let me bring up a slide. Now, a key store contains my digital certificates. So for example, if I'm being challenged by a peer, I send one or more certificates from my key store, my repository, to the challenging peer, and the challenging peer then does verification of those certificates. By contrast, my trust store is a repository of the digital certificates that I trust. So when I challenge my peer and get certificates back, I compare those certificates against the contents of my trust store. The difference between the key store and the trust store has to do with functionality, not format. So for example, one and the same file could serve both as a key store and as a trust store. With core Java, you have a built-in trust store. It's called CA-certs, as we saw last time, but you don't have a built-in key store, and we're going to have to create one eventually. Now, with this distinction in mind, let's turn to the source code. Let me bring up my Emacs editor, and the file you're looking at is called Google Client Short.java. The full running client is Google Client.java. Both files are contained among the working files. So let me make a couple of points, then we'll get to the core part of the code. You can see at line 1, we're going to be using something called the HTTPS URL connection. It's a subtype of the URL connection that we've seen earlier. And at line 2, you can see the endpoint. It's got HTTPS as the so-called scheme, and you can see the port number at the end is 443. That's the standard port number for servers to accept HTTPS connections. Down here at line 3, we open the connection using a URL once again as the object reference. And here basically in the comment, you see the output from a sample run. Now I'm going to return to the Cipher suite momentarily. The line above it, you see the status code is 200. So the client sends a GET request to Google over HTTPS, gets back 200, the standard OK for a GET request. And the first line of output is something called the Cipher suite. The short version is this is a list of all of the algorithms that are in play. Of interest right now are the 3 certificates that Google sends back. So each of these certificates needs to be verified against my trust store. And in this case, my trust store is the default one, CA-certs under JRE-lib security. Now, let me come down to the Cipher suite, which I've repeated here just for convenience, and talk a little bit about these acronyms. So the first one, TLS, stands for Transport Layer Security. So that's the S in HTTPS. This is a derivative of the earlier SSL from Netscape, Secure Sockets Layer. You'll sometimes see TLS and SSL used interchangeably. The next algorithm is quite a mouthful, elliptical curve Diffie-Hellman key exchange. This is essentially the handshake algorithm, and the handshake is the process that the client, in this case, the Google client code, and the server, in this case, the Google server for the home page, this is the process they go through to establish an HTTPS connection. We'll come back and study that in some detail. RSA, named after 3 researchers who started this company, is the public key cryptography algorithm. Basically, it's the algorithm used to create a key pair, which consists of a public key, which is on the certificate, and a private key, and we'll return to that as well. AES 128 GCM, another mouthful. The AES stands for American Encryption Standard, and the GCM stands for Galois Counter Mode. The 128 is the size of the encryption key used to encrypt messages that go back and forth across the wire. We'll return to that as well. And SHA 256 is the hash value algorithm. This algorithm is used for integrity. In other words, an outgoing message has a hash value attached. On the receiving end, that hash value is recomputed and the two are compared. If they're the same, we assume that the message was received intact. If not, we assume there's a difference between the sent message and the received message. Sometimes this hash value is described as a fingerprint, although that can be a little bit misleading. Now, down here in the dump details utility method is where the printing occurs. So as you can see, the connection is passed in as an argument. We get the response code. Down at line 4, we get the cipher suite. That's what we just looked at. And then we iterate through the certificates that Google happened to send. So Google, and this is not uncommon for commercial sites, sends us 3 digital certificates. In the minimalist case, you might send back only 1.